Hello, New Enterprises class. My name is Greg Sachs. I am a System Design and Management Fellow with the class of 2007, and I am putting together this rather impromptu video to explain this technology. Now, energy storage is one of the key enablers to the smart grid revolution. We talk about doing a paradigm shift from our fossil fuel carbon-based economy to a post-carbon economy. The problem, of course, is that renewable sources such as wind, especially, solar and tidal, ocean, some other ones, they do not provide a consistent and level energy supply. So what's important is the idea of decoupling, separating the supply side from the demand side. And this, of course, requires a buffer and energy storage. There are a number of types of energy storage out there. One of them that we're familiar with, you may have heard of, is pumped hydro, where when the cost of electricity is low, you actually pump from a lake to a reservoir on a higher elevation. And when the cost of energy is very high, you can sell that energy back to the grid, push it back on the grid by running the water back from the reservoir and running a generator. The round-trip efficiency of a system like that is approximately about 70%. There are other types of energy storage. The batteries, of course, is one method. Problem with batteries is that while they may be great on small scales for for laptops and other devices, they are not very good on larger scale, grid size. Sometimes they are used in medium-sized applications, but they have many issues, and they're not very portable, and there are a lot of maintenance involved. Batteries are very challenging to work with on a large scale. So my idea, which actually isn't just my idea, it's mine and a colleague's and a few others, but I'd like to pull this together for this class, is using compressed air for the generation and storage of energy on a short-term basis. Compressed air storage is not new. You've probably heard it being used for in large caverns deep under the earth, or mines or caves where they actually pump energy into this location, and essentially that compressed air acts as a spring which you pull the energy out of, unwind the spring, when the cost of energy is very high. There's a sophisticated air pumping system with a blower and compressors to enable this technology. Now the key difference with what we're proposing is to do it on a small scale. And this is through the use of an alternate means of storage, such as one idea is using pipes. And there's various ways to do the analyses for this, but essentially you have a large bank of pipes, and you could essentially put them in some sort of container, or ship them in a container, or bring them in on a flatbed, and you would bank them together to the appropriate size of the application. So this has several benefits, one of them being that it's scalable. You can size up or size down. It is deployable, so you could put it in the location that the renewable energy plant, say it's a wind farm, is actually located. You don't have to try to find a cave that's next to wherever you want to put this plant, because you don't have a lot of flexibility over either of those things typically. So, and I believe it's also going to be cost effective, and I think the business case, the economic case, will prevail when we start to dive into the system design and the numbers. There are a lot of potential customers. Primarily, we'd be selling to utilities. They would probably be interested in a system like this, or, like I said, to couple with renewable energy generation plants themselves. So the value proposition is in the not so much in the sale or in the manufacturing of the actual components. I think that there's a number of OEMs out there that will be able to supply this stuff, but where I think the value that we could bring is in the design and integration. In other words, the construction of these things. And then there's the second business case, which would be in the owning and operating them, ownership operate, and maintenance too, O&M. So a little bit of background on me. I am actually the Chief Technology Officer of a small startup on Long Island. We're a 12-person renewable energy firm, and we have a lot of background in these particular issues, such as how does the grid operate, and I have a particular background in a lot of power plant engineering. So I think that we can put together a rock star team, and we can tackle this thing and come up with a very legitimate business case for short-term compressed air energy storage. So with that, give a thumbs up on the side of the screen here, and let's do this.